Welcome, my name is Dr. DrWedding, and this is DrWedding DC08. Solving series circuits. In this video, you will learn what a series circuit is and how to find all of the values in a series circuit. A series circuit is the easiest type of circuit to understand and solve. Series circuits are just a loop, and there are no branches. Solving a circuit means you will know the voltage across each of the resistors, the current through each of the resistors, the resistance of each of the resistors, the total voltage, the total current, and the total resistance. Solving series circuits is very easy. You just need to follow 4 simple steps. Step 1. Generate a table or a chart that will hold all the information about the circuit. Step 2. Fill in the known information. This means copy the given information on the circuit into the corresponding sections of the table. Step 3. Use 3 rules to find the missing information. All of the missing information on the table can be calculated if you follow 3 rules. The 3 rules are: Rule 1. Ohm's Law. Ohm's law has been covered in a previous video, but as a quick review, the equation for Ohm's law is V equals IR. If you have any 2 values for a component, you can find the third value using this equation. When using this equation, V is in volts, I is in amps, and R is in ohms. Rule 2. Current is the same throughout the circuit. A series circuit does not have any branches, so all the current that enters the circuit flows through the circuit and exits at the same rate. This is like a garden hose. If water enters the hose at 2 gallons per minute, then the flow inside the hose is also 2 gallons per minute, and water will exit the other end of the hose at 2 gallons per minute. Because the flow is the same throughout the hose, it is impossible to have 10 gallons per minute exit a hose when 2 gallons per minute is entering it. Rule 3. Resistance is additive. Resistance is additive means that the total resistance is the sum of all of the resistors. If you go to the store and buy 3 items and one costs $5, one costs $3, and one costs $6, then your total bill is $14. The same applies to the resistance in a circuit. If your current has to go through a 5-ohm resistor, a 3-ohm resistor, and a 6-ohm resistor, then the total resistance your current passes through is 14 ohms. These 3 rules are very easy to apply to a table because Ohm's law will apply to each row of the table. If you have 2 of the values, you can find the third. The second rule is only applied once. When you find any current, you just copy it into all the current boxes. The third rule is also only applied once. If you have a missing resistor, you can calculate it because all the resistors will add up to the total resistance. Step 4. Copy the new table information onto the circuit. This is done so you can see the direction of the current flow and which side of the resistor is the high side and which is the low side. This will become very useful as the problems become more complex. In example 1, I will step through this circuit in great detail so you will understand each of the steps. As the steps and rules are implemented, the updated information will be highlighted. Step 1. Generate a table to store your answers. The table will have a row for each of the resistors and a row for the power supply. The power supply is the row at the bottom of the table and is labeled total. Step 2. Fill in the known information onto the table. In this example, you know the resistance of the 2 resistors and the total supply voltage. Step 3. Repeat the 3 rules until the circuit is solved. The 3 rules are: 1. Ohm's law. 2. Current is the same throughout the circuit. 3. Resistance is additive. Start at Rule 1. In this chart, Ohm's law applies to each row, but this does not help you because you do not have 2 values in any row. Advance to Rule 2. This rule does not help you because you do not know any of the currents. So you advance to Rule 3. Because resistance is additive, You can add R1 and R2 to get the total resistance. 150 ohms plus 250 ohms is 400 ohms. So the total resistance of the circuit is 400 ohms. Fill this value in on the table. Once you use Rule 3, you know all the resistances. And this rule is no longer useful, so a line was drawn through it. A new value has been added to the table, so you should start to step through the rules again. Start at Rule 1. This time, you have V total and R total. Using Ohm's law, you can calculate the total current exiting the supply. 12 volts divided by 400 ohms is 0.03 amps. Fill this value in on the table. Now that you calculated a new value and put it on the table, you can start checking the rules again. Start at Rule 1. But this does not help you because you do not have two values in any row. Advance to Rule 2. You now know the total current is 0.03 amps. In a series circuit, current is the same throughout the circuit, so you now know the current through R1 and R2. Fill these values in on the table. Once you use Rule 2, you know all the currents. And this rule is no longer useful, so a line was drawn through it. Now that you have filled in all of the currents on the table, you can start checking the rules again. Start at Rule 1. This time, you have the resistance of R1 and the current through R1. Using Ohm's law, you can calculate the voltage drop across R1. The voltage across R1 is 150 ohms times 0.03 amps. So the voltage across R1 is 4.5 volts. Fill this value in on the table. Now that you have filled in the voltage drop across R1, you can start checking the rules again. Start at Rule 1. This time, you have the resistance of R2 and the current through R2. Using Ohm's law, you can calculate the voltage drop across R2. The voltage across R2 is 250 ohms times 0.03 amps. So the voltage across R2 is 7.5 volts. Fill this value in on the table. Step 4. Once the table is filled in, copy the new table information onto the circuit. You know the current is the same everywhere, so you can add the current to the circuit. The magnitude of the current is 0.03 amps. Because we are using conventional current flow, we assume the current is flowing from the positive terminal to the negative terminal. So arrowheads are added to indicate the direction of the current. If we were using electron current flow, the only difference would be the direction of the arrowheads. In the case of electron current flow, the arrows would be pointing from the negative terminal to the positive terminal. You also know the magnitude of the voltage drop across each resistor. This information can also be added to the original circuit. The last step is to add a plus and a minus to the voltage drops across the resistors. The current enters R1 on the left side, so that is the positive or high side. This is marked with a plus sign. The current exits R1 on the right side, so that is the negative or low side. This is marked with a minus sign. The current enters R2 on the right side, so that is the positive or high side. This is marked with a plus sign. The current exits R2 on the left side, so that is the negative or low side. This is marked with a minus sign. This is the complete solution for this example. Example 2 is a circuit with 3 resistors. If you wish, you can pause the video and try to solve the problem by yourself. After you restart the video, the complete solution will be given. To solve this problem, you follow the 4 steps as before. Step 1. Create the table. Step 2. Fill in the known values. Step 3. Repeat the 3 rules until the circuit is solved. First, use Rule 3. Resistance is additive. This gives you the total resistance. Second, use Rule 1. Ohm's law. This gives you the total current. Third, use Rule 2. Current is the same throughout the circuit. This gives you the current through the 3 resistors. Fourth, use Rule 1. Ohm's law. Apply this rule to each row, one at a time. This gives you the voltage drops across the 3 resistors. Step 4. Copy the new table information onto the circuit. Solving a series circuit is very easy because it is just following the 4 steps in order. Example 3 is the final example. In this circuit, you are given a different set of starting conditions. Solving this problem is the same as the previous examples. The only difference is the rules are applied in a different order. If you wish, you can pause the video and try to solve the problem by yourself. After you restart the video, the steps to solve this problem will be given in order. To solve this problem, you must follow these steps. Step 1. Create the table. Step 2. Fill in the known values. Step 3. Repeat the 3 rules until the circuit is solved. First, use Rule 3. Resistance is additive. This gives you the total resistance. Second, use Rule 2. Current is the same throughout the circuit. This gives you the total current and the current through the other 2 resistors. Third, use Rule 1, Ohm's law. Apply this rule to each row. This gives you the voltage drops across the 3 resistors and the supply voltage. Step 4. Copy the new table information onto the circuit. Hopefully this video has taught you how to solve a series circuit. These problems will be used to solve more complex problems later in the course. If you find these videos helpful, please like the video, leave a comment, and subscribe to my channel. This is the only way I can continue to make these videos.